All right, hey, we're back for part 2. I'm just going to jump right in because this is the 2020 sample question that was released earlier this week. It has 1, 2, 3, 4, 5 parts. Okay, so let's just get to it. Let me get comfortable. Okay, so like all of this is question number 1. It's just that like 2 parts are on the front, and those are the 2 parts that I did in the first video, and then the rest of it's on the back. And it's like a second question, but that's why it starts with a part C, because it's all considered number 1. Okay. Anyway, let's take a look at what we're given here and see where we're going. Oh, this is good. I like graphs because I like looking at pictures because I can barely read. No, I'm kidding. I know. Alright, I'm sorry. Let's just go. The continuous function f is defined over the closed interval from -6 to 5. We see a portion of that graph from -2 to 5. That's important to note. And it tells us some information. These are line segments. This is the curve of a quarter of a circle centered at the point 5, 3. And it tells us the point at x equals 3 has a y-coordinate of 3 minus √5. That'll be needed for one of the parts of this problem. All right. In part C, we are asked if the integral from -6 to 5 of f of x dx equals 7, then we are supposed to find the integral from -2 to 6 of f of x dx and show the work that leads to our answer. Alright, I'm going to be honest with you. I just, like, in the interest of time, I knew I didn't want to have to try to write all of this stuff out, and I also did not want to have to, like, type it out in, like, an equation editor. So I did something that I hope you can see and make sense of. This part is cut off. We will definitely ignore this part. Can I write on here? Okay, yeah. Alright. So ignore that piece because I'll rewrite it over here. But I want to show you what I did, and I'm just going to sort of talk it through. Let's get rid of that, and I'm going to make this bigger for a moment. I'm just going to like send to bring forward. Does that work? Yeah. Alright, I'm just going to make this bigger for a moment to talk about it, and then I'll go back and write some things here to finish it up because it's not done. Okay, but this is my initial thinking, and I just wanted to show you my initial thinking. The way I actually wrote it on my paper. Like, this was just me doing it for myself, for my answer key. Alright, so first of all, I just put this little thing up here because I think maybe that's helpful for you to keep in mind that if you're asked to find an integral, then that is doing the area. If you are asked to do a derivative, then that is looking at the slope. Okay, especially when you have a problem that involves a graph, most likely part of it is going to be where you need to do the area, and that's going to be your integral parts, and you will have to also do parts where you'll need to think about the slope at different points, and that will be, you know, your derivative. Okay, so I know that because in part C I'm asked for an integral value, I'm looking at area. And, you know, sometimes we say area under the curve, but really keep in mind it's area between the curve and the x-axis. So the first thing that I did, let's just start with the first little part. I just shaded in all of the different pieces that I was going to need to calculate the area for, and I did that. I calculated each area, and I just wrote them here. So, like, I just wrote them along, you know, sort of under the graph or near the pieces. Alright, so this piece is triangular region, area is 1/2 base times height, so that's a pretty easy calculation. The area is 1/2. This triangle, okay, this took me a moment to figure out. I actually wrote this little equation right here of this line segment. Y equals 2x minus 1 is the equation for that line. And I just used that to verify that this x-intercept right there, okay, see where I put that dot? That is at x equals 1/2. Okay, that's really important to know that, first of all, if this line has a y-intercept of -1, you can see that, and you're going up to right 1, up to right 1, you know, all along this line for its slope, the equation of the line is 2x minus 1, and that can verify that, again, right here, this is at x equals a half. The reason you need to know that is you need to know that the base of this triangular region, okay, this triangle has a base along the x-axis, and it is 3 halves. It's 1 plus a half, so it's 3 halves. It has a height of 1, and so the area of that region is 3/4, 1/2 times 3 halves times 1. But since it is below the x-axis, notice that I made it negative because for the purposes of calculating a integral value, that would be considered negative. All right, next I looked at this triangular region, knowing that this is a half and this is 1. This is also a base of 3 halves, however, it's a height of 3, and so using my area formula for a triangle there, that's this one right here, area is 9/4. And finally, this piece. Let's talk about this piece. All right, let me grab a different color. So what you need to look at for this piece is the fact that it's what remains out of this square. I can't draw straight. Okay, let's try it again. What remains out of this square? You get the idea, right? That square, by the way, what's its area? It is a 3 by 3 square, so it has an area of 9. Okay, the piece, though, that you need to calculate the area for that I shaded, it's what's left out of that square when you take out this quarter of a circle. Now, since you know that the center of this quarter of a circle is right here, you know that the radius of this quarter of a circle is 3, and so the quarter of a circle would be pi r squared, pi 3 squared, 9 pi, divided by 4, because it's a quarter of a circle. And that's what you're seeing right here. So this 9 is the area of the square that I outlined in green. This 9/4 pi is the area of the quarter of a circle that I just outlined in red and did a little weird squiggly. And so the area of the shaded region that we need is 9 minus 9/4 pi. Okay. All right, so that sets me up to be able to answer part C easily. Okay, and here's why. Take a look at this piece now that I wrote above part C for my work when I did it. I used a property of integrals. It's called additivity. At least that's what I call it. That says that if you have the integral from one interval and then you pick up with the upper limit of that first interval to do another integral, okay, you can add those pieces together and that gives you the overall. Now why that's helpful is, take a look at this right here. We are given that the integral from -6 to 5 of f of x dx equals 7. So I'm going to replace this integral with a 7. Now I know the answer to the integral from -2 to 5. This one can be found by just taking the sum of all of these areas, just adding them all up. And so the answer to what I'm trying to find, which is this integral, will be 7 minus this integral sum. Okay, just to make things quick, I think you can add and subtract. I have faith in you that you can do that. When we take that sum, I'm just going to tell you that answer. This is what got cut off right here. It's 11 minus 9 pi over 4. Okay. And so, the answer to part C, the integral from -6 to -2, is going to be equal to 7 minus that sum. Now make sure to put that sum in parentheses like that. Okay, and you could leave your answer like that actually. For the purposes of AP scoring, that would be considered a completely correct answer. You could simplify. I just couldn't help myself. I distributed the negative through. Make sure to distribute that negative to the negative 9 pi over 4, and I decided to write my final answer like this: 9 pi over 4 minus 4. 7 minus 11 is -4. Okay, so that's the answer to part C. That's my final answer. And it said show the work that leads to that answer, and we did. Okay, showing all of this work did. I didn't talk about this. This was sort of just a visual representation of what I did right here, what I set up right here. I knew that the overall area from -6 to 5 is 7, because again, that was given to us right here. I then said, this is what I'm trying to find. I'm trying to find the area of this region that I don't even see a graph for. And how am I going to do that? I'm going to take 7 minus all of these areas. All right, so that's basically what you're doing. All right, let's move on to D. In part D, we're just doing another integral calculation. However, we're not doing an integral of the function f. We're doing an integral of f prime. So we can't use any of the areas that we calculated in part C to answer part D. All right, right here, I think I should probably mention to you that one of the things about AP free response questions is just getting over how scary they look. This just kind of looks intimidating, to me at least, and I've been teaching AP calculus for, I don't know, over 10 years. So I can imagine that for a student doing this for the first time, it looks scary. You're like, what the heck am I supposed to do with this? Okay, you're supposed to do the steps that you usually take when finding the answer to an integral. Find an antiderivative. It's a definite integral, so you don't need to worry about plus C, okay? There's probably going to be no place on the AP exam where you need to worry about plus C. So those memes won't help. All right, find an antiderivative. Use the fundamental theorem of calculus part 2 that says take the upper limit in your antiderivative minus the lower limit in your antiderivative to get your integral. Okay, if you just follow those steps, you will be fine. There's just one little, I don't even think it's a tricky part, just one little part where you're going to have to think about how to evaluate. Okay, but let's just first start with something simple. The antiderivative of 2f prime of x is 2f of x, right? The antiderivative of a derivative is its function. I hope I said that right. Somebody will probably let me know if I didn't. The antiderivative 4x is, or I'm sorry, I just said it. The antiderivative of 4 is 4x. Okay, there we have it. We have the antiderivative. Now let's evaluate from 3 to 5. And that means, I'm going to put my work way up here, I know I have a video somewhere in here. I don't see myself when I'm doing this, but I know I'm down here somewhere. Hi. All right. I should just mention constant multiple of 2 just comes along. That's a property of integrals. That's why I could just bring that 2 down there. Okay. Now let's fill in the 5, the upper limit. So 2 times f of 5 plus 4 times 5. There's my f of b. I'm doing this right now. This is what I write it as. Capital F of b minus capital F of a, and that is capital F standing for antiderivative of whatever's in here. All right, so there's my capital F of b minus capital F of a is 2 times f of 3 plus 4 times 3. And now we're ready, and here we go. It's a TikTok reference, sorry. Okay, so now we got to figure out, like this is 20, right? Nice and easy. This is 12, nice and easy. What's this? Okay, what's f of 5? Well, that says go to f, go to x equals 5 on f. What's the y coordinate? 0. Do the same thing for f of 1. 2 times, what's that? Go to 1, go to x equals 1 on the graph of f. What's the y coordinate? It's 1. No, I have a mistake here. I thought that was a 1 because my writing is so bad. I'm sorry. That's a 3. That's a 3. That's a 3, right? That's a 3, that's a 3, that's a 3. Okay, I was like, wait, there's supposed to be a root in here because I already did this. I did the work ahead of time this time. All right, f of 3. Sorry, erase this one. F of 3, what's that? That's not a whole number. That's not an integer value. What is that? Oh, it's right here. Okay. It's 3 minus root 5. They had to just throw something in here to make this one a little bit weird, right? There it is. No, this is 0. This is 20. You know, some AP teachers would say, in the interest of time, leave your answer like that and move on. All right, you got bigger fish to fry than doing little calculations. I, again, sometimes can't help myself. I took 20, I distributed the 2 here. I took 20 minus 6 plus 12. What's that, 2? And then the 2 distributed here is, oh, I'm sorry, no, it's 20 minus 6 minus 12. Sorry, that's why I'm getting a 2. And then negative 2 distributed to the negative root 5 is positive, yep. So I did simplify, but again, if you're worried about time, don't do those little simplifications. Just move on. Okay, so that's the answer to part B. All done. It just said evaluate, no explanation there. You just do it. All right, E, the function g is given by g of x is the integral defined function. Really important to note that it is starting at negative 2, going to x of f of t dt. So that basically says it's starting here, and g is defined by the area anywhere from negative 2, beyond. We are finding the absolute maximum value of g on the interval from negative 2 to 5. Justify our answer. All right, really important stuff right here. I feel like you're going to see something like this. And the first thing that I need you to know is that if you have a continuous function on a closed interval, then you are dealing with the extreme value theorem. The extreme value theorem says you must be able to find an absolute max and an absolute min over that interval given. So we will be finding an absolute max, and whenever EVT applies, the way that you test the possible maxes or mins is you do, and just like function value comparison, or in other words, I've heard teachers call it like a candidate test. Okay, let's just call it what it is. It's an XY table. Or I'm going to set it up as a x g of x table. I'm trying to find the maximum value of g. If I find the highest y coordinate of all of the g, the possible places where it could be the highest y coordinate of g of x, then, that's my answer. That's what I need to find. So what you're going to do to start this table is you're going to figure out what x's go here. And what x's go here are the places where you could possibly have a max or a min, your possible extrema. Okay, possible extrema are always going to come from your endpoints and then critical points. Critical points are where the derivative equals 0, or where the derivative does not exist. Okay. Before we do that, I think it's really important to note something that you should think about here. I'm just going to really simplify the g of x function that was given to us over here. It said g of x is the integral from negative 2 to x of f of t dt. Let's just do this so that we can think clearly about the relationship between g and f. Because here's the problem. You're asked to find the absolute maximum of g. You don't have the graph of g in front of you. You have the graph of f. You don't have a whole lot of information at all about g, except what you really need to know is that g is the integral of f. Okay? Or if I'm trying to find critical points, that's where g prime equals 0. All right, in terms of f, that is just f, right? Let's go through like our little list of things here. This is actually going to help us with another part as well. I think it's part G. If g is the integral of f, g prime is just f. Does that make sense? Differentiate both sides. The derivative of an integral, those are inverses, so you're left with the function itself. Then you could even go a step further if you like for later on. You might just want to have this written somewhere to help you, now that you're working with this g, which is an integral defined function. Okay, here's everything that we have. G is the integral of f, g prime is f. So the function values of f are the same as g prime, and g double prime is f prime. All right, so for this part, I'm looking for where g prime is equal to 0. Well, that's actually where, on my graph, f is equal to 0. Okay, the other critical points could come from where g prime does not exist, and that would be where f does not exist. But notice that there's no discontinuities, there's no holes here, or asymptotes where f does not exist, so we don't need to worry about that. So where does f equal 0? That's where it crosses the x-axis. It crosses here, here, well, and the endpoint, but we already have that listed. Okay, so my other possible extrema are x equals -1 and x equals 1/2. Remember that we talked about in part C that we know that this is x equals 1/2. All right, so now just find the y coordinates at each of those x coordinates, I mean the y coordinates of g. Okay, so like right here I'm doing g of -2, and keep in mind that your g function is defined here. So g of -2, just replace x's with -2's. What's the integral from -2 to -2? It is 0, right? By the way, that's definitely not going to be a max, because if I have an endpoint and it's positive to the right of the endpoint, that means that that endpoint is a min. Not that you need to worry about that, really. All right, g of -1, that's what we're doing next. G of -1, go back to this g function, sub in -1 for the x's. What's the integral from -2 to -1 of f? It's 1/2 because it's the area, which we already calculated. By the way, that possibly could be our absolute max, because the derivative is going from positive to negative around -1 means it's, definitely a relative max, okay, or a local max. G of 1/2 is actually not going to be a possible max, because the derivative goes from negative to positive, meaning that's a min. Could put it in here anyway just to have a complete table. What's g of 1/2? I think it's -1/4, looking at that area. So what I did there, just real quick in my head, is I said if this is 1/2 and this is -1/2, those cancel. So what's left for g of 1/2, sorry, is this piece, the area of this piece, which is 1/4. And finally, g of 5. Okay, this is also a possible max, because it's an endpoint and the derivative is positive to the left. So increasing to a right endpoint would be a max, and that one is, let's go back. That one is the answer to this integral right here. 11 minus 9 pi over 4. Okay, so it's definitely not this one, as I already talked about. It's definitely not this one. So just the question here is, which is a higher y coordinate, 1/2 or 11 minus 9 pi over 4? It's this one. Okay, this is calculator allowed, so you could check that in your calculator. It's like 3 point something. If you want to give the decimal y coordinate instead of the exact, you would need to make sure to go to 3 places. So actually type it in your calculator, round to 3 places. But just to save us some time, I'm just going to write right now that this is the absolute max. Okay, you should probably write it out again at 5 comma 11 minus 9 pi over 4. Justifying your answer is this work. Okay, the work is justifying your answer. You could say a little bit more like because it is the highest function value out of the candidates for extrema. Okay. All right, after that one that was kind of messy, and it was a lot of work coming up with that table and all of those values. Here's one that's nice and simple. Let's take a look at this. Usually when I see a limit, I'm like, oh, thank goodness. I love limits. But, okay. Still a little tiny bit of work of, thinking about certain pieces here. When I first did this one, I was like, oh, this is going to be 0 over 0, and we're going to have to use L'Hopital's rule for sure. It wasn't. Okay, what's the first thing you should always try when evaluating a limit? I'll tell you, direct substitution. Take that x, sub it in, see what happens. You need to make sure you're getting an indeterminate form before you do something else. Never forget that. It's so important, and I think that it is not emphasized enough. I try to, but you learn all these different techniques for finding a limit that it just sort of gets lost sometimes. Or maybe you have trust issues with math, and you're like, it's not going to be that easy. All right. So, subbing in 1 for the x's, I get 10 to the 1, which is 10. Minus 3 times f prime at 1. So let's do that. F prime at 1. What's that? Okay, f is here. The answer is not 1, okay, because it says f prime at 1. That's actually the answer here. So what is f prime? F prime is slope, right? Don't forget the thing that I wrote at the start. If you're looking at a derivative of something, it is the slope of that something. So if we're looking at the derivative of f, we're looking at the slope. The slope of this line everywhere is up 2 over 1, up 2 over 1. So that's a 2. In the bottom, we have an f of 1. That means go to when x is 1. And what is the y-coordinate on the graph of f? It is 1. Minus, we have the arctangent of 1. Now, if this was non-calculator, which I think that they could possibly do in other years, you would just need to know this one, but it's calculator allowed. Anyway, the arctangent of 1 is pi over 4. Okay. So now we just need to simplify, and I only simplified slightly here. I took 10 minus 6 in the numerator and made that a 4, and I left my denominator as is. No sense in doing anything else with that. Don't waste your time. That's a good answer. That's a pi over 4, by the way. 4 over 1 minus pi over 4. Sometimes I think I'm writing really well, and then I go back and I watch the videos later, and I'm like, that looks horrible, and nobody's going to understand it. This is 4 over 1 minus pi over 4, people. Okay, let's move on. To the last part, finally. All right, this one's actually not so bad. We're using the same g of x function that was described to us in part E, and so I'm going to put that little bit of information that I had right here back up. G is equal to the integral of f. That means that g prime is f. And we will also need to go one step further. I'll discuss why in a moment. G double prime is f prime. Okay, so the question is the rate of change in G increasing or decreasing at t equals 1? Explain your reasoning. All right, so you're not going to do a ton of calculation here. The most important thing to do in this question is interpret what the heck it's asking you. Is the rate of change in G increasing or decreasing? Okay, let's just interpret this part. Rate of change in G. How can you write that? It's not G. It's not asking you if G is increasing or decreasing. Okay, then it would just say, is G increasing or decreasing? It's saying, is the rate of change in G increasing or decreasing? So here's what it's asking you. Is G prime increasing or decreasing? Okay, so first, just rewrite the question in terms of what it's actually asking you for. It's not asking you to think about G, it's asking you to think about G prime. All right, next, unless you are looking directly at the graph of what you're being asked for, it's very hard to determine whether something is increasing or decreasing. So is G prime increasing or decreasing? Well, that's tricky because we're not looking at the graph of G prime. All right, you can't just say, yeah, look, that's increasing, so yeah. It is increasing, but it's not because you're seeing increasing here necessarily. Okay, so the next step is that you should, remember that if you're trying to figure out where something is increasing or decreasing, what you could figure out is where its derivative is positive or negative, whether the derivative is positive or negative, and that will actually, answer it for you. So is G double prime positive or negative? Is asking the same thing as what the question is asking. Okay. Now keep in mind that we're looking at the graph of f, so we kind of want to have everything in terms of f here, and so I go up to my little key of information here and I change G double prime to f prime because I have a little equation right here that tells me that those are the same thing. So is f prime positive or negative? If you can answer that question, which you can do very easily, then you have answered what part G is asking you for. Okay, so now keep in mind we're specifically looking at t equals 1. Honestly, I think that's a little bit of a typo. I actually think it's supposed to be for x equals 1. At least that's what I looked at here. I thought about questioning that more, and then I was just like, I feel I don't know. Sometimes College Board puts stuff out and then they have to go back and fix it later, and I kind of think that's what happened here. I don't know. I probably should have asked them people before doing this video, but let's just go with it because I know this is what it's asking for. Okay. Where was I? Oh, is f prime positive or negative? We're looking at, in particular, x equals 1. So is f prime at 1 positive or negative? Well, f prime, remember, going back to that little bit of information that I wrote at the very beginning, f prime is a derivative, so its slope. Is the slope at 1 positive or negative? Well, we know the slope is 2 throughout the interval from x equals 0 to x equals 2. So the slope is 2, which is positive. Since f prime is positive, that means g double prime is positive. That means g prime is increasing. That means I'm not going to write this out because it'll look horrible anyway, but your answer should be, you should write it out as a sentence. You should say the rate of change in G is increasing at x equals 1 because f prime of 1 is positive. Okay. F prime is the same as G double prime, so it's basically saying everything you need to explain your reasoning. All right. That's it. I hope that you found this helpful. I wish you all good luck. I'm not doing another video because I just don't have enough time and they're stressful for me. So good luck, everyone, and I know you'll do fabulous. Okay, bye.